The second type of transformation, whether it's linear functions or anything else that we're going to talk about, is reflections. There are two reflection rules that I want you to write in your notes. First of all, to reflect any graph across the y-axis, you take the original function and you change it so that the sign of the x is reversed. That little green negative sign inside the parentheses, that means change the sign of the x term. So if it's positive, it goes to negative. If it's negative, it goes to positive. And that is how you reflect any graph across the y-axis. To flip any graph across the x-axis, you take whatever the function is and you negate or change the signs of the entire function. That's what the minus sign on the outside means. It means change all the signs of all the terms. So you have to understand which reflection you are doing. So using those rules, let's practice. If you want to pause the video, please pause at this time to copy those rules down. Make sure you highlight them or put a box around them in your notes. All right, let's do this problem. Reflect y equals 2x plus 1 across the y-axis. And I really appreciate if you worked along with me to see how this works. First of all, I want to graph this, and I'm going to graph this in red. And we all know the y-intercept is equal to 1, and the slope is equal to 2. So therefore, I'm going to put a dot at 1, and then I'm going to go up 2 and over 1 and put a dot, up 2 over 1, put a dot. And that is the graph of this particular function. Now, I'm going to erase what I wrote about slope and y-intercept. And now it says, let's reflect this across the y-axis. Now, I'm going to go back a slide. In order to go across the y-axis, it says we need to change the sign of the x term. So I'm going to go back, and I'm going to take my sign, and I'm going to rewrite this f of x, this function, to reflect across the y-axis. I'm going to change that sign. So now I get y equals negative 2x plus 1. Now let's see how that works. Our y-intercept is still 1, but now our slope is equal to negative 2 over 1. So now I'm going to graph this in green. The y-intercept is still 1, but now I go down 2 and over 1, down 2 more, and over 1. And there is my graph. Does it look like it's a reflection across the y-axis? Well, it sure does. Here's the y-axis in blue, and it definitely took my red line and flipped it across the y-axis. And so it works. And so here would be the answer if I asked you what is the function that would flip y equals 2x plus 1 across the y-axis. Let's try across the x-axis. Now we just graphed this, so again I can put a dot at 1, and I'm going to go up 2 and over 1, up 2 and over 1. So I have my graph of my original function. Oops, that wasn't quite straight. Up 2 and over 1 is about right there. Up 2 over 1. See if I can draw this a little straighter. Now, we want to reflect this across the x-axis. I'm going to extend my line a little bit here. Now, going back a slide, it says in order to reflect across the x-axis, which is down here, I need to change the sign of the entire function. All of the signs need to be changed. So let's go back and try this. I take my original function, y equals 2x plus 1, and I take my function and I put the negative sign on the outside. So it's like timesing everything by negative 1. So I get y equals negative 2x minus 1. So let's graph this. The y-intercept now is negative 1, and the slope is now negative 2. So my y-intercept is down here, negative 1, and I go down 2 and over 1, down 2 and over 1, and my graph should look something like this. Now, if you notice, my blue line is a reflection across the x-axis. The graph has now flipped across that particular line, which is what I wanted to achieve. And that is how you transform functions and get them to reflect across the x and y axis. Again, if you have any questions, please make sure you ask me during class.